Hello everyone, welcome back to Piezo Physics. In the second video of trigonometry, we are going to see what are trigonometric functions and how they are defined and all these things. Okay, so now let us consider one right angle triangle here. Okay, so this is 90-degree angle and this is our theta. Okay, this is hypotenuse. Okay, and the adjacent side of this theta is known as adjacent ADJ. Okay, I am writing these terms in short. Okay, and the opposite side, this side, is known as opposite, OPP dot. Okay, so you have to always remember, if theta is here, then this will be adjacent side. If we take theta here, then this will be the adjacent side. Okay, so now we are going to see different trigonometric functions. First trigonometric function is sine theta. So we can take sine theta equals to opposite upon hypotenuse. Okay, second trigonometric function is cos theta. Cos theta is adjacent upon hypotenuse. Third trigonometric function is tan theta. Tan theta we can take equals to opposite upon hypotenuse. So basically this is just ratio of sin theta to cos theta. Our third trigonometric function was tan theta, and fourth trigonometric function is cosec theta. Cosec theta is equals to hypotenuse divided by opposite. This is just the reciprocal of sin theta. Our fifth trigonometric function is sec theta, which is just hypotenuse upon adjacent. We can take it equals to 1 upon cos theta. Okay, and our sixth and last trigonometric function is cot theta. So cot theta is just hypotenuse upon opposite, which will be equals to cos theta upon sin theta. Okay, so we have total 6 trigonometric functions. Okay, generally I remember 2 trigonometric function. First is sin theta and second is cos theta, and from these trigonometric functions I derive the another trigonometric functions. Okay, so generally tan theta is the ratio of sin theta to cos theta, and then we can see that cosec theta is the reciprocal of sin theta, and sec theta is the reciprocal of cos theta, and cot theta is the reciprocal of tan theta. Okay, so here we can see that this is 1 upon tan theta. Okay, so these are the trigonometric functions. Now let us look into the values of these trigonometric functions for some particular angles. Okay, this theta can be 30-degree, 60-degree, 45-degree, and 90-degree. Okay, so for these values, what will be the values of sine 30, sine 60, and sine 45, etc., etc.? This is 3 centimeter, 4 centimeter. So the squares of this will, so from these two sides we will have this as 5 centimeter. Okay, so this angle is taken as 37-degree. This angle will be equal to 53. So here we can see that sine 37-degree is equal to 3 by 5. Okay, and sine 53 will be equal to 4 by 5. Cos 37-degree will be equal to 4 upon 5, and cos 53-degree equals to 3 upon 5. So these are the sine values of 37 and 53-degree, and cos values of 37 and 53 degrees. From these values we can derive tan 37. So generally tan 37 is the ratio of sine 37 to the cos 37. This will be 3 by 4, and ratio of sine 53 to cos 53 will be tan 53-degree, which will be 4 by 3. Okay, so these are the few trigonometric functions. These values we are going to remember. Now let us make one table for all the values which are majorly used in physics. Okay, so here is the table of trigonometric functions. First we have sine theta. So sine theta's value for 0-degree angle is 0. Okay, and sine theta's value for 90-degree angle is taken as 1. Okay, so clearly I remember just one formula, which is 1 1 3 and 2, 2, 2. Okay, so just put division sign here and make two square roots over here. Okay, so these are the formula, which is 113 and 222. Okay, so you are going to remember these values for using this tip. Okay, so that you can remember it for longer time. Okay, now sine 37 we derived, this was 3 by 5, and sine 53 was 4 by 5. So to remember these values, I have one another tip. 37 here 3 and 3 by 5 here 3. Okay. So generally we have one right angle triangle which has three sides, 3, 4 and 5. Okay. So 3 by 5 and 4 5 by 5 values were there, and 37. Okay. So here 3 and 3. So this is how you can use your tip to remember sine 37's value, which is going to be 3 upon 5. Okay. Now let us see what will be the value of cos theta. Okay, so generally cos theta. Now let us see what will be the value of cos theta for different angles. Okay, so generally I start from here. So 1, just put 1 over here. Okay, so now the value of cos 30 will be equals to sine 60. Okay, so now we are going in this direction. Okay, so next value will be 1 by root 2, and after that we will have 1 by 2, and cos 90 will be 0. Okay, and these values will be interchanged here, 4 by 5, and this will be 3 by 5. Our next value is tan theta. Okay, generally tan theta is the reciprocal of sin theta to cos theta. Okay, so our next function is tan theta. Generally tan theta is the ratio of sin theta to the cos theta. Okay, so 0 upon 1 will be 0. 1 by 2 divided by root 3 by 2 will be 1 by root 3. Ratio of these two values will be 1. uh, Ratio of these two values will be root 3. Ratio of these two values will be infinite. Ratio of these two values will be 3 by 4, and ratio of these two values will be 4 by 3. Okay, so using these values you can just directly calculate the values of cot theta, cosec theta and sec theta. Now we know that cot theta is the reciprocal of tan theta, so the reciprocal of 0 will be infinite. 1 by root 3's reciprocal will be root 3. Here we will have 1, this will be 1 by root 3, this will be 0. Okay, here we will have 4 by 3, and here we will have 3 by 4. Okay, cosec theta is simply reciprocal of sin theta, this is infinite. This will be 2, will be root 2, and root 3 by 2's reciprocal will be 2 upon root 3. This is 1. Okay, here we will have 5 by 3, and this is 5 by 4. Okay, sec theta is the reciprocal of cos theta, so 1's reciprocal is 1. Okay, and here we will have 2 by root 3. Here we will have root 2. Here we have 2. This is infinite. This is 5 by 4. This is 5 by 3. So this is the values of trigonometric functions for the different angles which are going to be used majorly in solving physics problems. Okay, so simply I just remember this row, and using this row I just form another values of trigonometric functions over here. Okay, now let us move to the trigonometric identities. These identities we are going to remember. Our first identity we are going to derive in this way. Okay, so in right angle triangle we have the opposite square plus adjacent square equals to hypotenuse square. Okay, so if I divide this equation by hypotenuse ka square, okay, so we will have opposite square upon hypotenuse square. Here we will have adjacent square upon hypotenuse square, and on this side hypotenuse square divided by hypotenuse square will be 1. Okay, so opposite upon hypotenuse is just simply sine theta, so this can be written as sine square theta, plus adjacent upon hypotenuse, as we have seen this is cos square theta, so cos theta square will be cos square theta equals to 1. Okay, always remember if we have opposite upon hypotenuse, this is sine theta. Okay, you cannot put sine theta square. Okay, basically we put sine square theta. Okay, so this is our first equation, which is trigonometric identity. Now let us divide this equation with the cos square theta. Okay, so we will have sin square theta divided by cos square theta plus cos square theta divided by cos square theta. Here we will have cos square theta 1 upon cos square theta. Okay, so sin square theta upon cos square theta is just simply tan square theta, plus cos square theta upon cos square theta is 1, and 1 upon cos square theta. We know that reciprocal of cos theta is sec theta, so this will be sec square theta. Okay, our second identity is this one. Okay, again we can derive our third fundamental identity by dividing this equation with the sin square theta. That identity I am going to write it directly. Okay, sin square theta upon sin square theta will be 1, plus cos square theta upon sin square theta will be cot square theta, and 1 upon sin square theta will be cosec square theta. So these are the three trigonometric identities which we are going to remember. Okay, so that's it. After that, our second trigonometric identity is sine of a plus or minus b equals to sine a into cos b plus or minus cos a into sin b. Now let us put a equals to b equals to theta for sine of a plus b. Okay, so sine theta plus theta will be 2 theta. Okay, so sine theta here into cos theta plus cos theta into sin theta. So here we will get 2 sin theta cos theta. Okay, so this is the most important trigonometric identity, which is sin 2 theta equals to 2 sin theta cos theta. Our third trigonometric identity is cos a plus or minus b equals to cos a cos b minus or plus sin a sin b. Okay, so always remember, in case of cos a plus or minus b, here the sign of the sign will be minus and plus, not plus or minus. Okay, so now let us put a equals to b equals to theta for a plus b. We will get cos 2 theta equals to cos square theta minus sin square theta. Okay, so this is also another important formula. Okay, for third trigonometric identities, tan of a plus or minus b. Okay, so basically this is the ratio of sine of a plus or minus b to the cos of a plus or minus b. Now we know that sine of a plus or minus b is sine a cos b plus cos a sin b. Here we have sine minus divided by cos a cos b minus plus sin a sin b. Okay, so now let us divide this equation on numerator and denominator with the cos a cos b. Also here let us put cos a into cos b. So here we will divide this equation by sin a cos b cos a b plus or minus, here we have cos a sin b divided by cos a. Okay, here if we divide this term by cos a cos b, we will get 1 simply, minus plus, here we will have sin a upon cos a into sin b cos b. Okay, so cos b will be cancelled with the cos b, and cos a will be cancelled with the cos a. Okay, so sin a upon cos a will be equals to tan a plus or minus sin b upon cos b will be tan b divided by 1 minus plus sin A upon cos A is tan A into sin B upon cos B is tan B. Now, if we put A equals to B equals to theta for A plus B, we will get tan 2 theta equals to tan theta plus tan theta divided by 1 minus tan theta into tan theta. Okay. So here we have 2 tan theta divided by 1 minus tan square theta. Okay. So this formula you have to remember using this identity. Okay. So simply I just remember the value of sin A plus or minus B and cos A plus or minus B. Using that you can derive these formulas. Okay. Now we have one formula which is cos square theta plus sin square theta equals to 1. Okay. And we have cos 2 theta equals to cos square theta minus sin square theta. Okay. So sin square theta will be equals to 1 minus cos square theta. So cos 2 theta is equals to cos square theta minus 1 plus cos square theta. Okay. So cos 2 theta is simply 2 cos square theta minus 1. Okay. Minus 1 will be here. So it will be 2 cos square theta is 1 plus cos twice theta. So you will get cos square theta equals to 1 plus cos 2 theta divided by 2. Okay. If we put this value of cos square theta in this equation, we will get sin square theta as 1 minus 1 plus cos, here we have 2 theta divided by 2. Okay. So you will get 1 minus cos 2 theta divided by 2. This is sin square theta. Okay. So our sixth trigonometric identity is sine of A or minus sine of B equals to 2 sine A plus or minus B divided by 2 into cos A minus or plus B divided by 2. Okay. Our seventh trigonometric identity is cos of A plus cos of B equals to 2 into cos A plus B by 2 into cos A minus B by 2. Okay. Our eighth trigonometric identity is cos of A minus cos of B equals to 2 sine A plus B by 2 into sine B minus A by 2. Okay. So these are the eight trigonometric identities which you need to remember. Okay. Using these identities, you can solve any kind of trigonometric functions, and if this is used in any kind of physics problems, it will be simple and easier to solve those problems. Okay. Apart from this, okay, so our so if theta tends to 0, okay, so sin theta nearly equals to theta, cos theta nearly equals to 1, also tan theta nearly equals to theta. So basically we can say that sin theta is nearly equal to tan theta is nearly equals to our theta. Okay. And generally this theta should be in a radian, not in the degree. Okay. Here we can see that theta tends to 0 means theta should not be 0, but it should be nearly equal to 0. Like it is very small. Like you can see that sin 1 degree will be equals to 1 into pi upon 180. Okay. You cannot put here degree. Okay. Similarly, you can see sine of 2 degree will be equals to 2 degree into pi 1 upon 180. So this will be pi upon 90 radian. Okay. So this is how you can see. So this is how you can solve approximate conditions in which if theta tends to 0, then what will be the value of trigonometric functions. Okay. So this is all about trigonometric identities and all these things. In the last video of trigonometric series, we will see how to solve different values of trigonometric functions if the angle is more than 90 degree, right? So that's all for this video. Thank you.